due to the weather that we've been having, I'm kind of going to need you to get one of these lessons on your own so that we can keep up on our schedule here. Luckily, it's not that bad of a lesson. It kind of reviews some stuff we've done before. We've been working with similar figures and similar triangles, but now we want to go into what makes triangles similar. How can we go into proving that? And it kind of connects to some stuff we did earlier in the year. So if you look at your note sheet, if you've printed that out, earlier in the year we talked about 5 ways to make triangles congruent. So take a moment now and see if you can write those abbreviations for the 5 different ways that we told triangles were congruent. Okay, so if your memory serves you correct, we had side, 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 angle, side, angle, angle, side, side, angle, side, angle, angle, same thing, angle, side, angle, and hypotenuse leg. Okay, those were the 5 different methods we had for proving triangles were congruent. Well, similar triangles, we use some of these, but not all of these. So let's look at these 2 triangles. Are they similar triangles? Well, one thing I can do to prove similarity is know that if the sides are the same. So, well, actually, this is asking, are congruent triangles similar? Well, they are because our ratios, 5 to 5, 7 to 7, 9 to 9, they're all a 1-to-1 ratio of the sides. And the angles all stayed the same. Remember, we said similar figures have the angles are congruent and the sides are proportional. So yes, similar figures are congruent in a 1-to-1 ratio. Okay? Now, does that mean every similar triangle is going to be congruent? Whoops, I wrote that wrong. I wrote that wrong. Congruent, triangles are similar. There we go. Yes, so correct that. Got it backwards in my brain here. If they're congruent, they are similar in a 1-to-1 ratio. But are similar triangles congruent? This is easy to say no. So here I can see side, 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 congruency fails. So not all similar are congruent. And we even mentioned that in class the other day. Okay? So let's look at a couple of triangles and talk about their similarities. Are these 2 triangles similar? Take a moment, think about that, write your answer, yes or no, and explain why in a short sentence. Okay, so to see if they're similar, I'm going to look at the sides. So the smallest side of this one is BC, and the smallest side of this one is FE. The biggest side of that is that one. The biggest side here is 14. And if I cross multiply that, let's see, bring out my calculator. So 4 times 14 is 56, and 8 times 7 is also 56. So that one worked. So that checked 2 sides. So now I just need to check the middles. So I check the smallest and the largest. So the middle size side here is 5, and that matches with 10. And I just connect to either of these other 2. I'm going to use 4 and 8, just because I like small numbers. So 10 times 4 is 40. 5 times 8 is also 40. So that checks. So yes, these are similar. Triangle ABC is similar to triangle, let's see, AB was 7, so that's the big side. I went big to small, so big to small. D, F, E. We can actually write a theorem for this. This is the if all sides of 2 triangles are proportional, then the triangles are similar. That's the basic theorem. We abbreviate that. We abbreviate it by calling it, whoops, get that off of there, calling it the side, side, side similarity. Okay, so just like in congruency we had side, 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 for similarity we have side, 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 but we got to make sure to put this similarity piece here. And again, this doesn't mean that the sides are equal. It means that they're all proportional. Okay? So let's look at another type of example. Are these two triangles similar? Tell me what you think about this one. And again, tell me yes or no, and write me a reason you think so. So hopefully you said, well, let me try these sides and see. So 1.5 and 3, and 2.25 and 4.5. So again, I'll go to my calculator. Does that proportion work? So when I multiply the first two, I get 6.75. And 3 times 2.25 is also 6.75. So I've got my sides similar. I know AB to DE is the same proportion as AC to DF. The other thing I also know is angle A is congruent to angle D. So I've got two sets of proportional sides and the angle between them. So if two sides of two triangles are proportional and the angle between them is congruent, then the triangles are similar. And again, we can abbreviate that. Easy way to abbreviate that, this is the side angle side similarity. So the sides are proportional, the angle in between them is congruent. Okay? So real quickly, we're going to do some examples and see if you get this. If they're similar, and if they are, write the similarity statement. So try this first one. Are these two triangles similar? If they are, write a statement. Take a moment. Okay, so if I try this out, let me take the small side here. So that's 2.82, and the smallest side of this one is 1.41. And the largest side of that one is 7, and the largest side of this is 3.5. Okay, so right now that's set up two sets of my sides. The other set I'm going to look at is the 5.4 and the 3.5, and I'll compare that. Whoop, not the 3.5. I'm sorry, the 2.7, and I'm going to compare that to one of these two sides. But before I even do that, let me check to make sure this works. So 2.82 times 3.5 is 9.87, and 1.4. Whoops, clear that out. 1.41 times 7 is 9.87. So I've got two sets. I got to now check it with the third set. So I'll check it with another set here. Doesn't matter which one I choose. 4 times 3.5. That gives me 18.9. 2.7 times 7 is 18.9. So good. All my sides are similar. So I have AB matches with A prime, B prime. I have BC matches with B prime, C prime. And I have AC with A prime, C prime. So this is triangle ABC is similar to triangle A prime, B prime, C prime by side, side, similarity. So basically, if you're answered yes by side, similarity, I'm going to give you credit for that. So on your answer should have been something like yes by side, similarity. Ding. Okay, try another one. Are these two triangles similar? And again, tell me yes or no, and then give me a reason why. Okay, so when I look at this, let's see. I've got PQ is 3, PQ prime is 13, PR is 2, PR prime is 9. When I cross multiply that, 3 times 9 is 27, that's 26, and that fails. So no, sides not proportional. So our side angle side similarity fails in this case. Okay? Now, the reality, let's do one more. Let's do a quick little proof here. Okay? And I'm not going to do a full formal proof, but let's look at what happens when I prove this. Prove that these are similar triangles. So we're going to start the same way. AB is 8, AC is 10, AD is 12, AE is 15. So when I cross multiply, let's see, that's 10 times 12 is 120. I can do that one in my head. 8 times 15 is also 120. So I can say AB to AC is the same as AD to AE. So there's the side-sides part of this. I can also say that angle A is congruent to angle A by the reflexive property. Remember doing that earlier in the year? Okay. Well, now I can have, here's my proportional sides, here's an equal angle. So now I can say that triangle ABD is similar to triangle ACE by side angle side similarity. And that's a basic proof. We'll go in more detail later in the week. Now, in reality, we don't use these two things that much. Okay? So the easiest way to prove things, because doing all of this, we don't often get numbers in proofs. So the easiest way to prove things is to actually use what's called the angle-angle theorem. And it says if two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. And we just abbreviate that. You could do just angle-angle. Some people put the similarity there just to have it, but you can just write AA and you're fine. With the other two, you need similarity. We don't have an AA congruency. How does this work? We'll take a look at this problem. Are these triangles similar? Well, I see angle ADE is congruent to angle ABC. That's given. I can also say that angle A is congruent to angle A. That's my reflexive property. So that means triangle ADE is similar to triangle ABC by angle-angle. Easy as that. There's my other angle. Okay? Very, very easy type problem. Let's look at another one. Are these two triangles similar? Well, I see the 60 and the 60. Okay? But these are different. Real quickly, write why you think these might or might not be similar. If you said, hey, let me try this out, what is the third angle? So in this case, 60 plus 79 is 139, and when I take that from 180, I get that this angle is 41. Well, that means they can't be similar, because if that angle is 41 and that's 42, then they're not similar. Okay? No two angles are congruent. Good. All right, here's a thinking problem. I want you to try this out real quickly. One triangle has an angle of 120 degrees. Second triangle has an angle of 65 degrees. So we've got one triangle here, has an angle of 120. I got another triangle here, has an angle of 65. Can these triangles be similar? Why or why not? Write me an explanation. Okay, I'm not going to tell you the answer to this one. We're going to discuss this in class tomorrow. But I want you to have an answer and be ready to give it to me in class tomorrow. Okay? From here on out, it's just working on the problem set. Okay? Go through these, describe whether they're similar or not, tell yes or no, and then write which reason why. Either side, 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 angle, side, or angle, angle. If it's no, you don't have to write a reason at all. If they have the same symbols, that means like these both have an O. That means those angles are congruent. Okay? Do that. That'll get us set, so we'll be able to actually look at some proofs and get into doing a little bit of proving things when we get back into class. Okay, great. Have a good night.